Transformations practice questions. All right. So number one asks us to describe the transformations that are involved for each of the equations. So we're going to describe the transformations. Oh, wait. I'm going to do this on another piece of paper because I don't think this is sufficient room. So we're going to start with A. So A says our function y equals f of x has been transformed into the function y equals f of x plus 3. So the input has been replaced with x plus 3. And then we take away 6. So these are two transformations corresponding to our h and our k. And so this positive 3, suggests that there is a horizontal shift, aka a translation, 3 units to the left. Okay. Why left? Why not right? Well, if we think of our general formula for our general function, which is y is equal to a times f of b x minus h plus k. You know what? I just want to take a second to double check that those are the same letters we're using. I think I'm concerned that I got the h wrong. Depending on, it's not actually really important which letters you use as long as we're consistent, and some people use different letters. And I just want to make sure I'm not going to do anything confusing here. H of k. Okay, good. We're good. All right. So for this function, we can see that this h value is it's something. It's something such that x minus h is the same thing as x plus 3. So what does that mean? What's h? Well, there's a couple of ways we could go about this. We could actually solve this as an algebra statement. However, we could also say that in order to take away some number, so we get a positive value as a result, we'd have to take away a negative number. So, in other words, we could say x take away, maybe our h value is negative 3. And that would be the same thing as x is plus 3. And so that's why we are moving 3 units to the left, is because we have a negative value here moving in the negative direction of the x-axis. All right. So that's the first transformation. The second is that we have a vertical translation, 6 units down, which is maybe a little more straightforward and maybe a little more similar to what we've seen in the past. Okay, cool. Moving on. Question B gives us the function y equals negative 2f of 3x plus 4. Okay, so I see 3 transformations here. Oh, 4, I guess. So we're going to start with the value a. A takes the value from this function, negative 2, which gives us 2 transformations. It says the negative tells us we have a reflection over the x-axis, and the 2 tells us we have a vertical stretch, or that type of dilation, by a factor of 2. All right. Moving on. Oh, wait. So what do we got next? We have this value b. So b is 3. And so this tells us there is a horizontal, and I know it's a dilation, but I'm not sure which one it is yet, so I'm going to leave a little space here. Horizontal something, it's either a stretch or a compression. and we'll come back to it, that's by a factor of, and it's always a factor of 1 over b, so it's 1 over 3. And the fact that this 1/3 is a smaller value than 1, is in between 0 and 1, that means actually it's a horizontal compression. Okay. And lastly, our k value is 4, which tells us we have a transformation. It's a vertical translation for units up. I'll write the word up as well. Okay, cool. Moving on to question C. All right, things are starting to get hairy now. Okay. So for question 3, I'm just going to write the function down. Y is equal to 3 f of half x minus 4. That's all minus 5. Take away 5. Okay. And so I think I'll start by writing down these letters. So A is 3, which tells us we have a vertical stretch. By a factor of 3. Okay. And then we have this b value of 1/2, which tells me we have a horizontal something, and that's by a factor of 1/2. So we'll leave a blank there until we figure out if it's a stretch or compression. That's by a factor of, it's going to be 1 over our b value, 1 over 1/2. I'll write that out. There's a couple of ways to think about that. 1 over 1/2. How many halves fit into 1? Well, 2. But maybe that's not the way that you like to think of it. Another way is that this is a division statement, 1 divided by 1/2. If I do 1 over 1 divided by 1 over 2, it's the same thing as 1 over 1 times 2 over 1, which again gives us 2. Either way, our horizontal stretch is by a factor of 2. All right, moving on. We've got our h value is 4. And so that tells us we have a horizontal shift or translation 4 units to the right. All right, and lastly, we have this k value, which is -5, and that tells us we have a vertical translation 5 units down. Okay. Moving on to question D. So D is where things get a little interesting. D. Y take away 7. That's equal to our f of 6x minus 3. Okay. So there's a few things going on here. We need to make sure this is in our y equals a f of, bx minus c plus, no, not c, sorry, I forgot we were using h, plus k form. I like c and d, sorry, h and k. Okay. And it's not. First thing we need to do is isolate y to get into this form. Okay, so we're going to add 7 to both sides. So that will give us the value y is equal to f of 6x take away 3 plus 7. Now we need to be careful here. Notice that this is not, there's not an extra set of brackets in this input in the same way that there is in our general function. So what's going to be important here, you know what, I kind of made that a little messy. I'm going to rewrite that a little bit more clearly. A, f, b, open bracket, x minus h, plus k. And I'm just going to cross that on out. So we need to address the fact that this doesn't look like that. So what's different? Well, it looks like the number that would normally be multiplying by x has actually been factored out of this expression. So we're going to factor this number, which is 6, away from this expression. So this is going to look like y is equal to f, big bracket. I'm going to factor that 6 out of this expression. So we just have a raw x living here. So I'm going to say 6 bracket, and I'm going to take out my 6. So that means I've got an x left. And just to confirm, I can multiply that 6 back into the set of brackets and get 6x. And this number is going to be the number that I multiply 6 by to get negative 3, which is a half. And all that is now we can add 7. So that is so wait, let's just to confirm, if I multiply 6 back in, I get 6x. 6 times negative a half, I get half of 6, or negative half of 6, which is negative 3. Okay, so this tells me that my b value is 6. So therefore, there is a horizontal compression by 1 over 6, which is a sixth. Okay, my h value is 1/2, which means we have a, I'm going to start abbreviating here, horizontal translation. No good way to abbreviate translation without it looking like transformation that I know of, so I'm going to keep writing translation. And that's 1/2 a unit to the right. I like to draw little arrows as well. Okay, and then we're going to add 7. So what do we have here? That's our k value. Our k value is 7, which means we have a vertical translation, 7 units up. Okay, so a little bit more going on in that question. We're going to see E is a little more of the same. So I'll get a new piece of paper here. All right, so 1E. I've still got another not isolated y, and that's all equal to half of f of negative 2x plus 10. And I need to get that all into the form y equals a f of b x minus, not c, h plus k. All right. So a few things that are different. First, my y needs to be isolated, and it's not. So first thing I'm going to do is I'm going to take away 3 from both sides. So that gives me y on the left-hand side is equal to a half negative 2x plus 10, and take away 3. So still, again, we have this non-factored interior, non-factored input of this function. So as a final step here, I'm going to factor out the number multiplied by this x. So I've got a half f. I'm going to factor out a negative 2. It's going to leave just an x there. And I'm going to write a number here such that when I multiply negative 2 by it, it gives me negative 10. Or in other words, what is positive 10? You know what? I think I just said negative 10 when I meant positive 10. Let me just rephrase that. I find a number such that when I divide it by, or multiply it by negative 2, it gives me positive 10. In other words, what is positive 10 divided by negative 2? The answer is negative 5. And then I've got negative 3. And that allows me to answer, what are my transformations? I've got my a value is a half. So this tells me I have a vertical compression by a half. My b value is negative 2, which means I also have a horizontal compression by 1 over 2. And in addition, this negative means I have a reflection over my y-axis. So some A and B values give us multiple transformations because they can also hold a reflection. H is 5, which tells us we have a horizontal translation 5 units, right? And lastly, our K value is a -3, which means we have a vertical translation 3 units down. Okay. So I'm not going to be writing out my A, B, H, and K values for all of the following examples. So I'm going to be jumping straight to listing their transformations. All right. So let's look at number 2. Number 2 asks us to draw the transformed version of this function. So I think it's wise to first list the transformations. So I've got this negative implies I have a reflection over the x-axis. I have a horizontal expansion by 1/2, which is 2. We're going to have a horizontal shift to the right, 3, and a vertical shift up, 1. Okay. So what do we do first? We're going to do our dilations, and we're going to do our reflections, and then we're going to do our translations. So we'll do our dilations first. I can see I have a horizontal expansion. That's my first dilation. Then I have a reflection, so I'm going to do that next. And I'm going to do these guys together. So first thing is a horizontal expansion by a factor of 2. So that means I'm going to take each of my values, and I'm going to take my x, my y's, and I'm going to replace it with the value 2x, y. I'm not actually going to do that for all of those points, write it out, but I am going to choose 3 of these points. I'm going to say I'm going to start with this point here, and this point here, this point here. And so this point 2, 2, let's start with -2, -2. So that means -2, -2 is going to go to 2 times -2, which is -4, but my y value remains the same. So I've got a new point at -4, -2. It's also true for 0, 0. It's going to go to, well, it's not going to change. 2 times 0, 0, so 0, 0. And my point 2, 2 is going to go to the point multiplied by 2 on my x value, so I'm going to get 4, 2. So we get a new point at 4, 2. And I think it's wise to connect the dots a little bit. I like a nice little dotted line, so my diagram hopefully doesn't get too messy, but I at least have indicated how the nature of the shape has connected. I'm not drawing a straight line between them, for example. Okay, so let's choose a new color. I'll choose red for my next step. So next, I have my reflection over the x. So that's like saying, well, I'm going to start with my 2x and my y's, and I'm going to change them. And a reflection over the x-axis takes my y values and makes them negative. So that means I'm going to start with my value -4, 2. No, sorry, -4, -2. I'm going to multiply it by, the y value is going to multiply it by -1, so it's going to become -4, 2. So I'm going to draw this point at the point -4, +2. 0, 0. Well, -0 is 0 still, so no change there. And my point 4, 2 is going to multiply by -1 on the y value, so give me 4, -2. So 4, -2. Now you don't have to be writing these out every time. If you are comfortable just doing the graph one step at a time, that's fine. I'm trying to write at least the first example out with a lot of different steps, and you can choose a method that works better for you. All right, and next, step 3, I think I might only have another black pen, so I think I'll just wish I had a blue pen. Maybe I do. Let me just check. Maybe Mr. Watt has a blue pen that I can steal from him. Don't tell him. Nope. That's it. All right, fine. We'll use black. All right, so the last step, that means my point 2x and negative y. Negative y is going to convert to, so my 2x, well, okay, my horizontal shift, 3 units to the right, is going to add 3 to my x values. And my negative y values are going to be having 1 added to them, so negative 1 y plus 1. Okay, so we can start with the point negative 4 and 2, which is this value here. And that's going to change to negative 4 plus 3. So it's negative 1. And 2 is going to have 1 added to it. So it's going to be negative 1, 3. So the way we really can do this by cutting down some work is we can take our points and count 1, 2, 3, and then up 1, which actually gets us point negative 1, 3. Okay. I'm going to write the value in here. I start with the point 0, 0, and that shifts the point, add 3, so 3 and 1, 3, 1, count from the origin, 1, 2, 3, and up 1. Or lastly, we have this point 4, negative 2. And that's going to, we're going to add 3 to 4, so we're going to get 7. And the negative of 2 is going to, we're add 1 to that, so it's going to give us negative 1. So 7, negative 1. All right, and so my final curve is going to look something like this. Don't obsess too much about how you connected these dots, but I think you do want to what's the word I'm looking for? Conserve some of the nature of that graph. So if it seems to drop down and then even out and then drop back down again, you kind of want to conserve some of that. So what you don't want to do is draw a straight line through these. All right, so for the next example, I'm going to go through that a little bit more quickly. So if you think this example is a little quick, I advise you to go back to my walking through of 2A so that you can get this process a little bit more slowly done for you. All right, so I'm going to go quickly through this. I'm going to write out my transformations. I'm going to first isolate my y value, so it becomes, I'll take 4 away from both sides, because y is equal to 2f of negative 2, x plus 1, and take away 4. And so that gives us 4, 1, 2, 3, 4, 5 transformations. Oh gosh, okay. So we're going to expand vertically by 2, compress horizontally by half. Okay, now I'll move on to my reflections. So I'm going to reflect across the y-axis. I've got a plus 1 here, so I'm going to shift 1 unit to the left. I'm going to move down 4 units. And these are in order, actually. I'm going to start here. These are dilations. Then I'm going to do reflection. Then I'm going to do my transformations. Pardon me, my translations. I'm going to do those in one step. Okay. So this is going to seem a little abbreviated because I don't want to spend all day going through this worksheet, but I'm going to try, hopefully this can help a little bit. So first I'm going to expand vertically by 2. So all my y values, I'm only going to focus on these 3 points. I'm going to get multiplied by 2. So 0.05 becomes 0.010. 6.5 becomes 6.10. And 3.0 becomes, well, 3.0. So after my first step, I get something that looks like just a skinnier v, like so. Okay. Then I'm going to compress horizontally by a half. So what that means is that all of my x values are going to be multiplied by half. So the point 610 becomes the point 310. The point 30 becomes the point half 0. And the point 010 remains 010. So I'm going to draw a little dotted v there. Okay, then we have a reflection across the y-axis, which means all these points are going to be flipping over. So this point was on 310. It's going to become negative 310. 010 is going to remain to 010, and the point 1/2 0 is going to go to negative a half 0, like so. So I'm going to connect down like that. Almost there. Lastly, I am going to shift left and down. So left 1 and down 4. Left 1 takes me to half here, so negative 2.5, and down 4. Left 1 and down 4. All right. So I'm going to use a ruler here to connect these dots. Oops. And mess it up, even though I'm using a ruler. All right. So again, I went pretty quickly through that example. If you thought that was too fast, I encourage you to look at my example for 2a, in which we slowed down that thought process a little bit. All right, moving on. Okay, so what's going on here? We're given an equation of a graph of a regular object and its reflected image. And we're going to try to write an equation for the image, including the domain. All right. So in order to write the image, I'm going to need to decide what transformations occurred. So it looks like, first of all, I'm going to start with my dilations. I'm going to start with dilations and then my reflections and then my translations. And if you are in the Pre-Calc 12A class, you might have heard Liam O'Connor suggest the acronym "Don't Recycle Toilet Paper." And maybe that can help you remember that we're going to do dilations first. Okay, so I can see, I'll start with my vertical dilations. Was it stretched? It looks like this image is twice as long. I'm just going to count that. It looks like twice. This one is 1, 2, 3, 4 high. And this one is 1, 2, 3, 4, 5, 6, 7, 8 high. So it looks like there is a vertical stretch by a factor of 2. By 2. Okay, so that's my first thing. Is there any horizontal compression or expansion? It looks like it's 1, 2, 3, 4. Wait, 1, 2, 3, 4 units wide. And this one is also as wide as 4 units wide. Okay, so there's no horizontal stretch or compression. Okay, so that's it for dilations. We're going to look at our reflections. I should probably write out the dilation, reflection, and translation. All right, that's what that refers to. Reflection, well, I think it's very clear that it has been reflected upside down, which is a reflection over the y-axis. Oh, pardon me, the x-axis. All right, and then once it's flipped and stretched, it looks like it's moved over to the right 3, to the right 3, and up 1. Now lastly, we have to see if we can rewrite this function with all these transformations. So what letters these correspond to? Well, this is an A. This means A is 2. And a reflection over the x-axis means actually A is going to have a negative 2. And then we have this, we're moving to the right 3, which means our h value is negative 3. pardon me, it's positive 3. And this up 1 means our k value is positive 1. So if our general function of y equals x squared is the function y equals f of x, we can rewrite it as a f of b x minus h plus k. This guy is going to translate to give, well, I know my a value, y equals -2, and that's going to be multiplied by this thing being squared. So I'm going to write a little set of brackets here to imply it's being squared. And then what lives inside? Well, my b value is, it is not stretched or compressed. My b value has a value of 1. It multiplies by 1, doesn't change it. So I'm actually not going to even include it. But it does have a value of 1 in this case. My h value is 3, so I'm going to say I'm going to take away positive 3. And then my k value is 1, so I'm going to add 1. And that, is my answer. Now I haven't finished with the domain yet. So the domain is now, if I bring this guy down, this looks like the smallest value is 1, and the largest value is 5. So my domain is x such that we're looking at the values in between -1 and 5 inclusive. And those x's are elements of the real numbers, meaning we're talking about all the values in between the integers as well as the integers themselves. Okay. And that's also a component of the answer. So let's try that again. All right, so a few things are going on here. I'm going to start with my dilations. So I'll start with my DRT. So my dilations we'll start with first. So we've got let's check my vertical dilations. So my original function has a height of 2. And my new function looks like it has a height of 1, 2, 3, 4, 5, 6. So you go from a height of 2 to a height of 6, it looks like I have a vertical expansion by 3. All right. So then we're going to talk about this horizontal expansion. Looks like it's also a little wider. So original function looks like it has a width of 4 units, and this one has a width of 1, 2, 3, 4, 5, 6, 7, 8 units. All right, so it looks like there is a horizontal expansion by 2. Next, reflection. So it looks like there is a reflection across the y-axis. This is a reflection over y. And it also looks like it was shifted, but it doesn't look like, if I look at the origin, say, it looks like it shifted up 3 units, but it wasn't shifted left or right at all. So it looks like there's an upward shift of 3. All right, and so if I want to give letters to that, I would say that means my a value is positive 3. Now these two both, so over y, actually that's a manipulation of the x, the inputs. Okay, so that means that my b value is negative because it's a reflection over y, and negative inverse of the expansion, so it means it's going to actually be 1 over 2. And then my k is 3. Okay, so I'm going to go through this one a little bit quicker. Now that I have all this information down, I should be able to rewrite this fairly quickly. If you think I'm going too quickly translating this information to this function, I encourage you to look back at the example 3a. All right, so my y value, instead of just being root x, I've got a vertical translation, so it's 3 root. And my b value is manipulates my input, so I've got a -1/2 x. And then we're adding 3 on the outside. Okay. So that's part of my answer. And now I have a new domain as well. Looks like the domain starts at -8 and goes all the way down to 0. So a domain is such that x is such that -8 is smaller than or equal to x, which is smaller than or equal to 0. And, of course, I'm talking about x being an element of the reals. Okay. Moving on. Okay, this looks interesting. All right, let's start with my dilations again. It looks like this is a little taller, a little longer than this one. And so my original function looks like it's 3 units tall. This one looks like it's 1, 2, 3, 4, 5, 6 units tall. So going from a height of 3 to a height of 6 means there's a vertical stretch by a factor of 2. And, all right, how about horizontally? Well, the width is 1, 2, 3 units, and looks like the width of this function is still 1, 2, 3 units. Okay, so no horizontal stretch. Is there any reflections? Yeah, it looks like there is definitely reflection upside down. You can see that if I draw this upside down, it looks somewhat like this, but not stretched. So there's a reflection over the x-axis. And that looks like we're almost done, except it looks like there's also a translation. So I choose a random point here, maybe this middle point, and say, well, it looks like it's the corresponding point on this upside down function is here, and the difference is 1, 2, 3 units. And the corresponding point here for this point would be over here, so it's another 1, 2, 3 units. So it looks like it moves 3 units to the right. And so that means my a value is 2. I have a reflection over the x. So actually, a is -2. And to the right, 3 means that I've got a h value of 3. So my new function, I'm going to... okay. So I'm going to multiply 2 by everything. Now, in addition to that, -2 by everything, because mine is -2. I'm going to replace my x with x take away 3. So that means I'm going to cube x take away 3, cubed. And I'm going to add x minus 3. That's kind of ugly, actually. I wish I had left myself a little more space. I'm going to write that out a little bit more expansively. Oh, and I forgot that 2. So 2 is multiplied by an x, but I'm replacing that with a new input of x take away 3. All right, now we should probably simplify this. Okay, x is -2, and that means x, oh god, x take away 3 times x take away 3 times x take away 3, and then it's adding to that, we're going to multiply that in, plus 2x, take away 6. Oh, this is gross. But I hope it's going to simplify a little bit. All right. So I'm going to leave that -2 out here for now. I'm going to draw a big bracket so that I separate it from these little brackets. And choose 2 of these to multiply together. It's going to give me x squared, take away 6x, plus 9. I skipped the intermediate steps there, but if you want to check it, please, I encourage you to try that yourself. Plus 2x, take away 6. Okay, and then we have to multiply all this by x. Okay, so it's going to have -2 x cubed minus 3x squared minus 6x squared minus 27 plus 2x, take away 6. All right, we're going to keep going. And so we see that we have some like terms, negative 3x and negative 6x squared, pardon me, and a negative 27 and a negative 6. All right, this is a heavy bit of algebra. And if you were going into calculus, if you're taking pre-calculus 12 to go into calculus, you're going to find that these sort of algebra skills, while they may seem tedious if you're unpracticed, can roll right out of your fingers if you kind of practice, which is why we're doing a bit of practice here. It's like just doing exercise. So negative 3x squared, negative 6x squared is negative 9x squared. We add 2x, and then we have these two like terms, which gives us negative 33. Almost done. Then we're going to multiply negative 2 out, so we get negative 2x cubed plus 18x squared minus 4x plus 66. Ugh. All right, and then we've got a domain. Domain is pretty straightforward. We're talking about x such that we're looking at values between positive 1 and positive 4. X is less than or equal to x, which is less than or equal to 4. And we're talking about x's that are elements of the real numbers. Okay. So I'm going to pause it there, and I'm going to start a new video to finish these thoughts on a new piece of paper. Let me know if you have any questions about any of the things we went over on those examples.